So you kind of take about, let's say 30% of your machine is already occupied, no change. Let's say about 20% of your machine here is occupied, no change. So it really only leaves you 50% of the machine to work with. And let's say we're going to introduce this material, which is going to be a side-fed material. So obviously you need the high advanced elements, high volume, okay? So we'll place that there. Because the material is coming in as a powder and it melts very quickly, you're going to have to cool the side stuffer. It's going to have to be cooled. There's no question, and you have to cool it. So at this point, if your polymer can handle a little bit of a temperature drop,
Yeah, sure.
if it can, then the best thing to do is you start with a reverse profile, and your processing conditions, let's say about 150. So let's say we start at 180, 170, 160. Okay, so we get your viscosity reduced as quickly as possible. You introduce the liquid. Now, from this point on, one of the things you're going to have to do is kind of give this liquid a chance to be incorporated into the polymer. So by mixing it very hard and having a lot of temperature, your viscosity separation is going to be greater. So what we'll do is, let's say we'll change the pitch a little bit, and we'll mix it just a small amount, okay? Because this will generate a little bit of heat on the polymer, but not on the liquid. And then we'll probably put another conveying element, because we want this stuff moving forward, and we're going to do it again. So ideally, what we're trying to do is try to regain contained viscosities, control of viscosity, and at the same time incorporate these liquids in slowly, okay? And then possibly another conveying element like that, and then a distributive mixer. This will be a good time to put this in to make sure that your polymer is homogeneous. You have a steady, stable process now. And I think by here you probably are in a very good place.